Now, hello and welcome. Today we are doing a very good question because this question may also come in calculus and mathematics, because when you have that, it's usually going to ask you, okay, you have something like this, it's going to be dropping, and then find out the units of that and try to find out the formulas. And what my calculus teacher, Dr. Panchal, thanks to him, always says, or even my math teachers throughout the year says, always draw what you're trying to see. Even Dr. Lane says that. So I'm going to draw that I'm in building 50, science and engineering building in UNF. That's what they actually tell us. And let's say the bigger circle is me, or I can say it's Austin in our physics class, or the grader, whoever that is. I think I have Miss Evans, so let's say Miss Evans is standing on top of the building 50. And she has a basketball ball in her hand, and that is a 0.6 kilograms. So you're going to say, okay, that little ball is 0.6 kilograms. And then we have the difference of the feet at 35 feet. On that, although I will say, standing at the top of the building 50 is not possible because I didn't see any stairs towards it. Or maybe actually on that side we have actually, I don't know. Anyways, we're going to have all these units, and now we're going to convert. And the first part of the questions tell us, find out this basketball, how far it's going to be fall in a unit of meters. So you have 35 feet. That's how far it's going to be falling. Then we're gonna do, okay, just like Dr. Sullivan said, we're gonna get the planning feet to meter. That's what we're gonna have. So I'm gonna cancel my unit of feet. I find out that in 1 meter we have 3.28 feet. So that my unit of feet are canceled. I'm remaining with the unit of meters. 35 divided by 3.28 is going to be 10.67 meters. Now we're gonna have the potential energy formula, which is U equals mgh degree times. So h we know is height, m we know is the mass, and then we have g, which is 9.8 joules per kilogram times meters. So we know if you want to have that, we also have the mass. We're going to use the height that we have for meters in order to find out, okay, when we are on top of this building with Miss Evans is on top of this building, how much potential energy we have when you're following this one up. So 0.6 kilograms times 9.8 joules joules per kilogram times meter. We're going to use that because that's the only one that we want to use. So kilograms cancel out. The meters with the 10.67 meters that we have is cancel out. We're going to remain with the units of joules. So since we're on top of the ladder, our potential energy is going to be 62.47 joules. Now, if you have it when it's actually hitting the ground, this is very easy to find out as 0 joules. Why? Because if it hits in the ground, the above the ground height is going to be 0. So you're going to have 0 meters. So no matter what we do with our units of conversion, we're going to have 0 joules. Because we're still going to cancel all our units out, but we have 0, so it's not going to do anything too much change of question. So now we're going to find out the kinetics based on what the question tells us. Okay, let's say for this part for kinetic, we have potential energy equals kinetic. So in order to find out the speed, we're going to say V is speed of the basketball. Joules is if you drag it out as a unit, it's going to be kilogram times meter squared over second squared. So in order to solve for V, we're going to find out, we're going to go all the way to this algebra aspect, trying to isolate V squared first, and the square root of all this reaction to get V equals square root of 2k over mass. So in order to get now the V, we're going to plug all the numbers. 2 times 62.74 kilograms times meter squared per second squared, from what we get from the kinetic, for the potential, being kinetic, over 0.6 kilograms, and then the square root of all whole thing. We're going to get 209 when we actually calculate this, because our unit of kilogram is going to be cancelled out through this algebra solution. We're going to get the V equals square root of 209 meters squared per second squared. So for answer, we're going to get 14.46 meter per second. We get the unit of meter per second for our speed, and we're going to get 14.46 as the speed of our basketball.